Now let us welcome our Senior Vice President and General Manager, Client Line of Business, Mr. Chris Bergey, to come up to the stage.
你好. Well, thank you, CK, and thank you, all of you, for coming out today. It's wonderful to see a full house. We've got some standing room in the back, and it is just a pleasure to be back in Taiwan. I think this is my 5th trip this year, and it's always fun and exciting. So I'd like to talk a little bit about Tech Symposia this year. We've got a 40% increase in registrations. And some other interesting metrics are a 52% increase in software developers. And this is actually super exciting because what I'm going to talk about today is some of the importance of software and software developers as we need to think about not always a hardware-first type of design methodology. We've got 27% increase in OEMs. I think that OEMs are realizing how important silicon is, and they really want to understand how ARM-powered silicon can impact their business, whether that be in the client space, whether that be in infrastructure, automotive, edge IoT. So I'd like to thank and welcome all these new faces. And today's discussion is about where we're standing today. And at ARM, we believe that this could be one of the most important technology moments of our lifetime. We've gotten to see the growth of the internet, what that has done to a connected world, and the impacts, mostly positive. We've seen the mobile revolution and what the smartphone has done and how it continues to evolve and drive more and more performance in our pocket and drive connectivity in the way we communicate and the way we share. But we believe that AI is going to just be yet another one of these moments with a tremendous opportunity in front of all of us. And we have the opportunity to really impact billions of lives with this technology. Now, there's enormous opportunity. It's also an enormous challenge, and I'm going to get into some more of that. But by working together, we believe that we can do more than we've ever done before. So in the past, if you came to one of our tech symposiums, we've talked about many of the different market segments that you all and we participate in. But this year, I'm going to do something a little bit different because we believe that AI is so pervasive that it goes across all of these segments. And we need to spend some time on AI and what does it mean relative to many of the diverse requirements of AI. What ARM's very focused on is building a compute platform for everyone. And that means the hardware, the software, and the ecosystem. And these three things are going to need to be more tightly coupled than they've ever been before. Now, ARM's been at this for 3 decades, building a platform, the world's largest compute platform with unmatched power efficiency. And we believe our insights and our decades of partnership can give us that platform to evolve this next generation of ecosystem partnership. So the same way that we powered the smartphone, we believe we'll be powering the platform for AI. And so whether you're building a next generation phone based on ARM v9, you're building a software-defined vehicle, or you're developing an AI-first data center, we believe the opportunity to partner and to work on the ARM platform is significant for all of us. Now, as I mentioned, this is not easy. The requirements around AI are very daunting. And we need to rethink the way that we create many of these computing elements. One of my favorite statements is one that I believe Google actually was maybe the first one that I heard it from, which is this idea of the package is the new motherboard. And we can see this evolving in front of our eyes, whether that's the chiplet ecosystem as we get into multiple chips inside of a die, the advent of 2.5D, 3D technologies, the memory bandwidth requirements around AI and the opportunity to co-locate memory, the amount of power that we spend on I/O and trying to keep that more closely coupled. This is a big part of the future. And of course, the island of Taiwan is going to play a huge role in this. We also see, more challenges around manufacturing. The cost of development continues to go up significantly. Cycle times continue to extend out. And then when you get into these advanced packages, that yet even more extends the supply chain. But we believe that we can solve these problems together. And that's what I want to spend some time on today, is talking about the potential. Now, again, AI has the potential to be this most important technology of our lifetime. And yes, we've used AI to unlock our phone or see some cool video tricks or remove people in the background from our photos. But I think for many of us, really seeing ChatGPT was kind of that first big bang moment for many of us on AI. And the way that we were able to hold a conversation and really feel like the computing element started to have intelligence and was able to communicate back to us and really make a rich experience. And of course, this has huge implications relative to education, relative to communication, and the like. But it's really going to change the way that we interact with technology. And of course, things are moving so fast. And now we're up to multimodal models. We've seen large language models that are being released at a crazy fast cadence that are just adding more and more intelligence relative to the engagement that you can have with these models. It is clear that there's almost limitless possibilities ahead of us. Some of my favorite examples of impacts that's already happening with AI is DeepMind. DeepMind recently won the Nobel Prize in chemistry. It used AI to predict protein structures. Now, many of you know that protein structures are really essential for everything that our bodies can do, from contracting our muscles, to sensing light, to turning food into energy. And by understanding proteins, we can start understanding deeply the causes of diseases. Researchers have been studying proteins and attempting to do this for over 50 years. And it was only DeepMind, by using AI, was able to map out these proteins. And this becomes significant, accelerating the research of life-saving medicines. For those of you who get involved with healthcare, you may know that R&D is actually the longest part of the drug research process. And they're seeing now up to 50% reduced times for clinical trials. This means we can get medicines faster into the hands of those people that need it so badly. Again, the amount of lives that can be impacted could be countless. But beyond AI helping scientists solve very complex problems, it's also enhancing our everyday lives. Currently, I carry the Samsung Fold, and actually using the live translate feature for someone that travels as much as I do is a game changer. To be able to interact with someone through a different language and really reduce that barrier for engagement and understanding. It makes travel much less intimidating. But there's even more impactful solutions than that. And one of the ones that I am super passionate about is actually the ability for AI to help those with disabilities. The World Health Organization believes there's about 2.5 billion people in 2030 that will suffer from disabilities. And those can be mental, physical, visual, hearing. So I'd like to point out, there's a Taiwanese company called Religent, that's making AI speech engine to support hearing impairments, and you can see the product blown up there. It allows it to separate voices in crowded spaces to allow conversations to be more engaging and more possible in a louder, more crowded environment. These kinds of applications are transformative, making our lives easier, whether it's researching medicine, simplifying the way we interact with the world. We are going to make the world a better place through the use of AI. So now let's talk about the role that Taiwan plays in AI. And in many ways, I see Taiwan as the epicenter of AI. Technology does not get into consumers' hands without Taiwan. And of course, 90% of the world's most advanced chips come from the island of Taiwan. But it's more than chip manufacturing. So many of you work in the flywheel of design, hardware, research, and software frameworks that are going to power these innovative applications. The world relies on Taiwan. And there's some complexities here, but we can do more than we've ever done before. So when we think about AI, I believe that we cannot think about it relative to individual problems. Everything is connected, and everyone is connected. And we really need to think about a solutions approach, where we've got seamlessly integrated together the hardware, the software, and the ecosystem working together. AI is more power and memory hungry than anything we've seen before. And every generation is requiring a massive amount of compute in a constrained environment, whether that be a megawatt data center or that phone in our pocket. Many of you, like I, can remember when we had room-sized mainframes, and we took on the challenge of taking those room-sized mainframes and putting the power on your desk. Then we took the power on your desk, and we figured out how to put it in your pocket. Those took some big steps to make those advancements, and we're going to be looking at the same types of advancements required to be able to truly deliver AI, not just in the largest data centers, but all the way out to the edge where it can impact people most greatly. The ARM compute platform is the fundamental thing we do at ARM. And ARM is a platform company focusing on giving you everything you need to get to the market quickly and efficiently. But we're really now thinking about the full stack. Everything from hardware at the bottom to the software and applications throughout the stack. Because AI tends to require heterogeneous computing. And what heterogeneous computing means is you're going to have multiple computing elements in the system. The CPU for sure, could be a GPU, an NPU, a different type of accelerator. And you've got to manage those workloads across those different applications. And you do it in a way that we can write software efficiently, and the developers can target that hardware. So we need to be mindful about how we put these compute components together. We can no longer just throw these blocks together and hack some software and believe that that's going to be a scalable solution for the world. Hardware is nothing without software. Now, many of us experienced and have seen some amazing hardware that fell short because the software wasn't great or, frankly, didn't exist. This software is not magic. It's written by developers, but we really need to think about a software-centric approach to building hardware in many, many cases. At ARM, we've been spending 30 years writing and optimizing software. And software has always been an integral part of the ARM compute platform. It's only going to get more complex, and there's going to be a lot of support needed. Software can be tremendously expensive and time-consuming. So investments need to evolve. One of my favorite stories is that I get the fortune to meet with some amazing leading-edge companies. And in the AI space, it's been very eye-opening, where we'll meet a startup company, 50 super smart hardware people, 50 super smart software people. They get going. They've got a vision. They start delivering those products to the market. I go back 18 months later, 24 months later. I say, how's it going? How's your growth? Well, Chris, we're getting our product out in the market. And I said, oh, well, how are you doing on your headcount? He said, well, it's interesting. We still have a 50-person hardware team, but we now have 400 software engineers. It's this is the world we're living in, right? This is the world where software becomes so important and so fundamental to the way you need to think about scaling hardware for the future. So in many ways, this is what ARM's focused on. We believe very much in this software-centric future. So first, you need consistent computing. You don't want to be worried about fragmentation in the hardware, and you want to make it so that developers can write once and deploy anywhere. Secondly, we're going to need acceleration capabilities. But the acceleration capabilities are needed in all of these areas of heterogeneous computing. And that's one of the reasons we're so focused on our ARM v9 architecture and what that can bring for the future of developers relative to running AI on the CPU. Software is what makes the ARM computing platform so unique. We now have 20 million developers developing on the ARM platform for ARM. And why did they choose ARM? Because it's the world's largest compute footprint. And it becomes this very virtuous cycle where we have more hardware, thus developers build more software. And that drives even demand for more performant hardware. And the cycle continues and continues. And it's throughout the stack. It starts at the bottom relative to the OS, and goes all the way up to the applications and the way that users engage with the technology. But a consistent computing platform gives the confidence for developers to be able to run well on the billions of ARM hardware that's out there today. Let's talk about an exciting new category of devices and hardware, the AI PC. Now, many of you have been super involved with the PC industry. PC industry lives and dies on this island in many ways. And ARM had pretty cool hardware back in the late 2007, 2008 type time frame with the Surface RT. But the issue is that ARM did not have the software. And as you know, it was not tremendously successful that go-round. But let's fast forward to where we're at today. We believe that the modern AI PC opportunity on ARM is tremendous, and tremendous for many of you here in the audience today. We now see that we have so many native applications that are running on Windows on ARM platforms. We've got a rich set of developer tools, and you're seeing more and more innovative applications for the AI PC. We're super excited about this opportunity, and we think you should be as well. But beyond the PC, we're looking at other ways to, again, make AI acceleration easier on the ARM platform. We need to be able to target these software stacks and be able to give people an easy, focused way to target these stacks and just have it run performant on the CPU. ARM's been making this investment in the V9 architecture and in our architecture for many, many years now. And we've been future-proofing this architecture through putting in many AI-centric features over the last several years, and it's not stopping. We made first implementations into AI over a decade ago into the ARM architecture. We brought in 64-bit with ARM v8, but it's really with ARM v9 where the AI era truly begins. So the next decade of ARM computing platform is purpose-built for AI. And all of these features are unlocked through the combination of software and hardware capabilities. Two key features that I'd like to point out today are scalable vector extensions, or SVE, and scalable matrix extensions, SME. SVE2 can be found in some of the leading computing products out there, like the new Dimensity 9400. And this can accelerate workloads to benefit developers and end users. SVE2 improves video and imaging, provides better quality photos, and provides better battery life for popular applications such as YouTube and Instagram. With SME, you'll see the next generation of architectural features that will provide, again, common instructions for developers to target once and be able to land on multiple pieces of hardware to get the acceleration that's possible in the ARM architecture. When you think about software developers, and I've talked about how important they are today, what you want them to think about is not how they're going to make it work, but what is it that they want to develop. And so we're abstracting so many of the hardware-specific aspects to really make it developer-friendly so you can focus on building great software and, again, focus on a simple integration. When I was here back in June at Computex, I had the pleasure to introduce Kleidi and Kleidi libraries. And this is basically an acceleration library that is going to accelerate the world's leading AI frameworks to run best on ARM out of the box. And when developers target these libraries, it takes advantage of the capabilities of the hardware underlying. And it provides even future-proofing for future capabilities like SME that I mentioned earlier. But this goes beyond mobile devices. And we've been able to show that we can take things like Llama 3 and literally in 24 hours have it be ported and optimized on Kleidi. But it goes beyond mobile. You can see PyTorch, ExecuTorch, from cloud to edge. These software frameworks will be accelerated and will run well on the ARM platform. there are acceleration opportunities for billions of AI workloads that'll be out there in the not too distant future. And you can see the performance, right? If I just look at PyTorch here, 2.5 times faster for time to first token based on ARM AWS Graviton processor when running Llama 3. It's just the start of our journey. You're going to see more and more optimizations, and there's more opportunity for collaborations across the ecosystem. But I want to again point out that the ecosystem, and so many of you, are so essential to the success and this future vision. We need solutions across software and firmware. We've got rising levels of complexity and packaging, as I mentioned. Foundry support is critical, whether that's from TSMC, Samsung, or IFS. So many of you are providing third-party IP. The SoC is ARM computing, but so much of the I/O, memory, and connectivity comes from all of you. And then finally, design services. There is such a shortage of engineers that understand how to build these super complex products, especially in the world of AI. And so the idea of how do we collaborate together, how do we leverage design services, how do we leverage different areas of expertise to put together an amazing platform for the future. And this is one of the reasons that we've put together our ARM Total Design platform and partnerships. This is a set of companies that are collaborating together in the ecosystem to focus on what they do so well, so that you can leverage that across your domain and to make a bigger product in a cost-effective, time-to-market efficient way. This program has been growing worldwide, and we've actually doubled the amount of members. And in fact, we have some great members that have joined from here in Taiwan just over the last year. Many of these platforms are based on our Nearverse CSS platform. So again, leveraging all the activities and what the companies can do best to create a broader and higher level solution. I'd like to point out a really cool example of this. So there's a startup called Rebellions, and what they did was they took the ARM AI CPU with an AI accelerator. They leveraged the CSS, they leveraged a 2-nanometer process node from Samsung Foundry, and they leveraged design services from Mayday Technology. So now you see, through the power of these partnerships, of these collaborations, that a startup can build something that we think that only the largest companies can build, a very powerful AI accelerator for data centers. This is the way that I encourage you to think about how can you leverage ARM CSSs, ARM's commitment to developers, ARM's total design, to create more impactful solutions for you and your customers, and how you can play in that broader ecosystem. It really is the power of the ecosystem. And we're also working on things like our chiplet system architecture. And how do we pull these chiplets together so that we can, again, be more efficient in this world of AI computing, where the costs and barriers to entry are so high, but the opportunities are so large. In conclusion, if I just go back to where I started, this is a tremendously successful ecosystem. So many of you have done so well, and it's been an amazing collaboration. But I really think we'll look back and say, we didn't comprehend what was actually ahead of us and what the opportunity was. AI is going to change everything. And we really believe that the partnership that we have with so many of you is going to make the future very, very exciting And we're super happy and super excited to partner with so many of you here in Taiwan. So what happens when we work together? Well, we actually believe that by the end of 2025, that there will be over 100 billion AI-enabled ARM devices in the world, many of you participating in that. But I'm only excited about the future that's even beyond this. So again, thank you so much for coming today, and I really appreciate the partnership we have with so many of you.